In the stillness of a dark room, where shadows dance and mystery lurk, we delve into the realm of mystery, lights and shadows of 3S. Join me if you dare.
Hola chamas y chamos, today we are going to talk about light and shadows using 3cs. Light is an essential ingredient in pretty much any form of art. It helps define form, add contrast that bring depth and evoke emotion. For example, The Godfather, directed by Francis Ford Coppola. This film used chiaroscuro lighting, which is a technique that contrasts light and dark to emphasize the character and create a moody atmosphere. You can also play with the color of the light to set the mood of the viewer, like they do, for example, in Blade Runner. And it's not different in 3D, where lighting plays a crucial role in determining how objects appear on the scene and how they illuminate the rest of the objects. So for example, in this scene that I have open in Blender, I'm playing with the light to give this spooky Halloween kind of mood. I'm using a diffuser light to give a little bit of ambient light, and then I have a key light here that is giving this color to the scene. If I remove it, you can see that the color is gone. I also place light inside of the pumpkin to make it look better. Now let's see how we can achieve this in 3cs. Right here I have black scene, okay? It does have some meshes inside. It has a torus geometry box and also a torus knot and a plane, but it's not visible because they're using the standard material and this material reacts to light, okay? And we haven't added any light to the scene. So the first light that we are going to add is the ambient light. This ambient light provides a light that illuminates the scene entirely and illuminates all the objects of the scene equally, regardless of the position of the rotation. So this one is an omnidirectional light that doesn't cast shadow, okay? It does simulate like a diffused light or an indirect light in an environment. So the way we can add an ambient light is similar to how we add other objects into the 3ds scene. So here we're going to create a 3 ambient light, and then we're going to pass some arguments via props. So this is going to take an array, okay? And if we check the types, the first argument is the color of the light and then the intensity. So for this one, we are going to add a white light, so FF, 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 and then we can add 1 as intensity. If we click Save, now we can see or actually seen, even if it is quite plain because it's using the same material everywhere and there is no contrast, there is no shadows, okay? You can also specify the properties like this. So you can pass the color, and let's say we want to add another color, it could be blue. And then we can also pass 1 for the intensity. Okay, we have the autocomplete there, and let's put it like 0.8. If we refresh, now we have a quite weird, kind of look bluish scene, okay? So if in any point you see your scene pitch black and you don't know what is happening, try adding a light to see if it's rendered correctly. If you want to check the code of this video or any of the videos in the list, you can go to GitHub as a repository called 3ds Basics, and here you can find all the code from this series on the 3ds Basics, as well as different branches where you can see the code for in each specific video. The next light is the directional light, and it's probably the light that I use the most because it's really simple to use. It emulates a light source from an infinite distance, so you can use it to simulate, for example, the sun. Okay, so the way you can do it in 3ds is basically here. We're going to add a 3 directional light, and then we're going to pass some arguments. The arguments are the same as the ambient light. We have the color and the intensity. So in this case, I'm going to pass as well a white and then an intensity of 1. If I hit save, now you can see that the scene is illuminated and it seems to be like it looks like it was a lamp on top, and that's because we haven't passed any position or any rotation. Okay, so it emulates like a lamp in the ceiling, okay, that is illuminating the scene. So if we want to change the position, we can do it. We can go here and say position and maybe translate it in the x-axis, put some height in the y-axis, and why not some depth. So if we click save now, we're gonna see that the light is now coming from a different direction. It's something around here. So it creates some core shadows on the geometries. The most simple one is a cube, so it looks really kind of weird. But for the torus and the torus knot, because they have more segments, it looks a little bit more diffuse. So we can even emulate the mood of the first plane on this video where the light is coming from above, from below, sorry. So the way we can do it is actually put it a negative one. So let's say in the x-axis, in the y-axis, we're going to put -2. And now you can see that it's coming from below. Okay. If we put for the position 0 and then set a 0, okay, now it's going to look even more dramatic. For example, the cube is really difficult to see because it's only illuminated the part below, but for the rest of materials here, it actually does the trick. Something that you might notice is that it's a little bit difficult to know where the light exactly is because it actually doesn't render any component or any visual aid, just illuminates the scene, right? So if we want to debug where our light is and tweak with it, we can use helpers. So the way to use the helper is trace directional light helper. But the helper has an argument that is really special because we need to pass the light in the first argument, and in the second one is expecting the size. So the way we can actually have a reference from the directional light is by using view template refs. So we use that to animate in one of the previous tutorials, and we are going to use the same approach to actually pass the reference into the helper. So we're going to say directional ref, okay? I'm going to copy here, go here and create a ref that is empty, okay? And this probably we need to import it from view, that's right. And here it's complaining because I didn't add the close, okay? So once we have the directional light, we need to pass here the first light and then the size. Let's put 10. If I click save, nothing is going to happen, and it's because I have an error in the console that tells me that it couldn't initialize because the directional light was empty. So if I do it again and I refresh, now we can see that we have a visual indicator of where the light is. So this is amazing because now whenever we're tweaking the position of the light, we can say something like this, 4 in the y-axis, okay? And now you can see that it went up a little bit. We can even translate it in the x-axis and say, okay, now I want to change the direction, so -10, and I don't know, like 50 here. So if I click refresh, now we can see that the helper went until this point. So this is essential to debug and create complex light scenes, okay? Something that you will notice is that if you change the color here, for example, and say orange, okay, and you refresh, you can see that the helper emulates the same color as the light, okay? What else? We can also do it in a different way because in CentOS package, the same that we use for the orbit controls, we can get the helpers. So there is a helper that is called the light helper, and this is going to be way easier to use. What we can do is remove the ref here and remove the tres directional helper, and just basically add here be light helper. So if we click save, now we can see that the helper is still there. It has a different size because we didn't set any size, okay? But as you can see, it's the same concept. So it's way easier now to just change the position. 50 is too much, so let's put like 10, I don't know, like keep playing like 5 here, okay? And we refresh, and now it's on the top, okay? So that's the way you can add helpers to certain lights, okay? Not all the lights have helpers, but the directional light is one of the ones that have it. Next in the queue is the hemisphere light, and this one is kind of cool. So for that, I'm just gonna change the color here to a normal white color, okay? So we have a pretty decent illuminated scene. And what I'm going to do is basically use tres hemisphere light, and this one is similar to the ambient light, so it's uniform and omnidirectional. The only thing is that takes two colors, one color that is resembling the sky and another one that is resembling the ground, okay? So if we pass the arguments like this and we say that the first one is red and the second one is blue, we are actually gonna have like this cool two light kind of 3D mood in the scene, okay? So you can see that the objects have these different tonalities of blue and red. Red is coming, I think, from the sky color. Yes, the first argument is the sky color, so the red is coming from above. And the ground color is the blue, so that's why the low part of all our geometries is painted blue. Let's now talk about the point light, and this light gets emitted from a specific point in all the directions, okay? The common use case for this one is just basically emulate a light emitted from a light bulb, for example, or a street light. Okay, so here you can see it. I already added it. So a stress point light. The arguments are the same, like the color and intensity, but I also add some controls here with tres leches to give the position, the distance, and the decay. So the distance is just basically the distance at which the intensity drops to 0, okay? And the decay is how much the light dims in the distance. So right now I have the light, and if I move it a little bit on the x-axis and then a little bit on the z-axis, and then come close to a material, you can see that now the material is being illuminated with this. If I go a little bit there and maybe a little bit down, here it starts to illuminate the floor and illuminate this, okay? So we can also play with the distance. So this is how much the light is going to illuminate, okay? So you can see that the more distance we add, the more illuminated it is. And then we can also change the decay, okay? So how much the light dims into it. So if we put the minus, it's going to do it the other way around. And here is like creating this blur effect of the light, okay? We also added a helper, so you can see it by using be light helper. So the point light is another one that has a helper to be able to visualize. So the next light on the list is the rect area light. And this one is pretty funny because it's exactly just that. It's a big rectangle that emulate like the real life Photoshop lamps that you have in the set. So it's a mix between a directional light and a diffuser light, and it accepts not only the color and the intensity, but also the width and the height. So to add it to our scene, we're gonna go here and say tres rect area light, and we're gonna pass the parameters. So let's see, okay, the autocomplete, nice. So width and height, we don't need to pass it because we already passed it on the arguments, okay? And position is just fine. So let's refresh. And now we can see that we have a light somewhere. And this one doesn't seem to have a helper though. I thought it had a helper, but it doesn't. So let's put another color that is gonna be easier to check. So like this one. And in the position, since it's on top, let's put something like 2 here. So maybe we can see it. Okay, so you can see that it looks like a rectangle. Maybe if I put it like really close to the floor, it's gonna be easier to see the light that emits. So here, perfect. Now you can see that it's actually a rectangle, right? So it's right here and it's illuminating. The color is not fuchsia though. Maybe hot pink. Now it's working as I expected. So here you can see the rectangle light, okay, and how much it illuminates, like it's really strong. We put it 2, but it actually does a lot. In this one, we can actually talk about another helper that will allow us to direct this rectangular light into a certain point. And that's, let's go here to the import and say be always look at. So be always look at, you can use it in any component, but we're gonna use it in the rectangular area light because be always look at, right now it's like looking, like directional to the center of the scene or the 0, 0. So if we wanted it to illuminate, for example, only the torus knot, let's check what we have our torus knot. So we have it on -4. And we can say, hey, look at -4, 0, 0. Let's refresh. And now you can see that it has rotate and is looking towards the torus geometry, okay? Now is the turn of one of the best lights available on 3CS, which is the spotlight. And the spotlight imitates a real life flashlight, just like in the video games, you can see it. So it's a cone that comes from a point and it goes in one direction. And it has several more properties that we can pass. So for that, I already prepared something with the controls. So here you can see it is this one right here that looks like a cone, okay? And we can change several properties like the distance, the decay, the penumbra, okay? And the position here. We are passing also the color and the intensity of it. So right now you cannot actually see it. So what I'm going to do is go down a little bit in the y-axis and you can see now that this is starting to interact with the floor. Okay, so if I increase the distance of the light, you can see that it really looks like a flashlight. So it's more intense here and then it dims a little bit. So if I change the decay, it starts like, it doesn't go to 0 that quick. So you have more space for you can control a little bit like between the distance and the decay, how much the light illuminates the scene, okay? So this is pretty cool and you can achieve like video game flashlights, for example. You can also have the penumbra, but to be honest, I don't know what it does. I guess it's that when you are aiming into a certain element, is giving you the contour of the actual light. And also the angle, we are not passing the angle here, but the angle will be like how large is the beam itself. So let's try to pass some angle and see what happens. If I pass mat pi between 4, okay, so maybe it's like the angle of the actual cone. Yeah, could be. What happened if I put, I don't know, like mat pi? Oh no, it's not that. Funny enough, it's the angle of the cone. Lol. Okay, now I get it. Lol, it looks really weird with this. So between 4 is the best one. Yeah, like with between four, it looks like this. Lol. So that's how you wrongly use a spotlight, okay? But now that we have seen the principal lights in 3ds, let's talk another topic. And is that if you have noticed now, all the lights are illuminating our objects, but they are only creating what we call the core shadow, which is the one that comes in the object itself. But if you see other objects like the plane on the ground, normally objects that react to light has a shadow that we call the drop shadow. So in this case, for example, it should be some shadows here. We have the directional light here, so some shadows should be casting on the plane. So let's learn how we can do it with 3ds. First thing that we need to know about shadows is that they are disabled by default. And why? Because calculating shadows and light and reflection is one of the most highly performant consuming operation in 3D in general, okay? So there are some techniques like baking the lights and the shadows to make the scenes more performant. But today we are only going to see how to create shadows and enable them on their scene. So I'm going to go to the code, and right now we have our scene as it was before. And the way we can enable the shadows is by passing to the trace canvas component the property shadows. So if we do that, we are going to be enabling the shadow maps on our a scene, but actually we cannot see them yet because we need to decide which objects cast and which objects receive the shadows. So the first thing that you need to do is add in the light that you want casting is to cast the shadow here. Okay, so you pass a property called cast shadow. Then you need to decide which object do you want to cast the shadow. So in this case, I'm going to tell it to the torus geometry to cast the shadow. Last but not least, we need the geometry that is going to receive it. So in this case, I'm going to select the trace mesh of the plane. So here we can say, hey, I want you to receive that shadow. Okay, if we click save and we refresh, now we can see that the torus is indeed casting a shadow on the floor. And this is quite cool because then we have enabled only for a specific component the shadow that it's going to have. If I want to add the shadow to the rest of the objects, so let's say this one here, let's go to this one here, so the box, and we want it to cast a shadow, and also to the torus node material as well. So now all the different objects on our scene has a shadow. What happens if I move this object right here, right? So let's move on the cube. So the cube is here. Let's say 4 and maybe 4. Okay. So now, no, it was too much. So 2, 2, and 2. Let's see if it works. Okay, so now it's in the middle, like here is the light, and is like creating an obstacle for the light. But we see that the light here, the shadows are overlapping, right? But it's not casting any shadow on the sphere. So as well as you can say that the sphere should cast shadow, you can also tell it to receive shadows as the plane for the sphere. So receive shadow. Okay, so now we can see the shadow being casted into the object itself. So I added some more shadows, like casting shadow from different lights. So now you can see that they are kind of overlapping a little bit. So you have this one here and this one here. The thing is that if you zoom in a little bit, you can see that they actually look kind of weird. It look like pixelated, okay? And this is because for performance reasons, the shadow maps, okay, that are created, and what basically 3GS is doing under hood is that it's creating these textures with the different information of the lights and the shadows that are on the objects. So it creates like a texture, and then it put the texture on top of the materials. And that this is called shadow maps. So the shadow maps are having like a size, like a width of 512 and a height of 512. But you can increase it by the order of power of 2, okay? So how we could do that, we are gonna take the directional light for this. And here we are gonna say shadow map size width, and we are gonna use, I don't know, 1K, okay? So if we save now, maybe we need to do it like this, okay. Now it's a little bit better, so maybe you cannot see it right now. Let's use 2K, okay, which is a lot, okay? But you can see that now it's more defined. It's not like this one is a little bit more defined. Another thing that we can use to optimize is the blur. So here on this one, we can add a directional light just below. Shadow radius, I think. 10. So if you do that and we refresh, you're gonna see now that the shadow it has like a blur, so it's way more diffuse into the audio. We can do the same, for example, for this one that looks really pixelated. So let's go here and say shadow radius, okay, and this will blur a little bit more, way more, like it really is unnoticeable anymore. So let's put like 5, and let's go back. Yeah, a little bit better. Maybe it's too much for this light because it's really subtle. Okay, I want to see another ones is the camera near and the shadow camera far, because basically 3GS use a camera to render the shadow maps. So you can tweak several stuff of the camera, like the near and far, like we did in previous tutorials. So if I put the far to be really small, what is gonna happen is that you are not gonna see it anymore. If I put something like 10, for example, now you have a partial view of the shadows. So make sure that the shadow far is quite high, so you have all your shadow like being mapped out. And that's pretty much for this tutorial today. All the code is gonna be on the description below. You're gonna have the repo with a specific branch, and you can tweak the different lights to play around and discover more.
Don't you dare to leave without giving a like and a subscribe. See you in the next one.